When the James Webb Space Telescope began collecting data, it gave us an unprecedented view of the distant cosmos. Faint, redshifted galaxies, seen by Hubble only as specks of light, emerged as objects of structure and form. Astronomers ran into a problem. These early galaxies seemed too advanced and too large to form within the accepted timeline of the universe. This triggered a series of articles that boldly claimed that the JWST refuted the Big Bang. A new paper now in the monthly notices of the Royal Astronomical Society argues that the problem is not that galaxies are too advanced, but that the universe is twice as old as we thought. It is exactly 26.7 billion years old. That's a bold claim, but does the data really support it? The model proposed in the article starts with something known as tired light. In the tired light model, the light spontaneously loses energy over time. As photons travel billions of light years through the cosmos, they are redshifted. Therefore, the light of distant galaxies is redshifted, not because of cosmic expansion, but because the light naturally reddens over time. The idea of tired light has been around since Edwin Hubble first observed cosmic expansion as a way to perpetuate the idea of a static universe. It lost popularity as the evidence for cosmic expansion became clear, and regained popularity as Webb observations began to spread. We've long known that tired light doesn't work on its own, so this article adds a new twist on universal physical constants. Quantities such as the speed of light, the charge of an electron, or the gravitational constant seem to be built into the structure of the universe. They have values because of the way the universe was formed and are generally assumed to be unchanging over time. We have geological and astronomical observations that show that the physical constants have not changed for at least a few billion years. Does the model work? Yes, but there are two problems with that. The first is that fine-tuning theories are weak theories. While this model can be made to fit the observational data, there is no physical motivation to do so. There are many models that can be adjusted to fit the data, which is not the same as having a solid physical model. The study's author argues that there may be some underlying mechanism that causes the tired light and physical constants to shift just right. But there's still a lot of trickery in the model. The second problem is that JWST's observations do not exclude the standard 13.7 billion-year-old universe. Galaxies are more complex than some computer simulations predict. But this is not surprising given the limitations of large structure models. There are many ways in which early galaxies evolved rapidly that did not require rewriting cosmology. Estimating the age of the universe is no different than estimating a child's birthday by height. Objects in the distance, in all directions, look a little redder than we expected from the signature light patterns. The most likely explanation is that space expands, separating these light waves like an arc. Because light takes time to travel, the redder light is the older light that has been shot over a longer distance. Working backwards on this estimated growth rate, it is possible to use expansion to determine when the universe was a compact volume boiling with concentrated energy. Gupta's hybrid hypothesis assumes that the universe, expanding to this size from a past Big Bang event, is indeed as big as we believe. It starts with two models of expanding universes. One is based on standard assumptions about the smoothness and flatness of the cosmos, and the second offers some fine-tuning involving what's known as a coupling constant. Bonding constants describe the interactions of forces between particles, just as the electromagnetic fields of two protons held close together affect each other's behavior in certain ways. All forces have a coupling constant that varies with energy, which is not necessarily constant. This leaves room for coupling constants to change enough to affect how light behaves. If this constant has changed over time, our calculations of the age of the universe could be substantial. Maybe this tired light model can explain the age of the universe. But as I mentioned, there are theories that contradict it. We have come to the end of the video. Thank you for watching and don't forget to like the video and subscribe. Bye.